In this video, we're going to look at visualizations in R. Specifically, we're going to look more at ggplot. Before we get started, as always, there's a couple of files you want to make sure that you have from Canvas. The first one is going to be the Lecture 5 script, and the second one is we're going to be using a data set that you've seen before. It's that student data set, so you'll want to make sure to also have that CSV file located somewhere on your computer, downloaded from Canvas. So before we get started looking at this week's script, there's a couple different things in RStudio that I'd like to show you that can be helpful. The first one is that RStudio does have a search function that will allow you to search through whatever file you're currently working on. So in this case, I've got a script open. You can also use this if you had created a notebook file. So you can access the search function by either clicking on the magnifying glass, or on your keyboard you can click on Control F, or if you're on a Mac, Command F. And so this is really useful because it can help you find different words in your script. I'll often use this, especially if I'm working on a really big script. And so, for example, I said later on in the video we're going to work with the student data set. So maybe I just wanted to look for where is the word student in the file so I can go directly to that section. So you'll notice I searched for student here. It highlighted the word student. And then up here I can kind of click through all the different places the word student shows up in the script file. And so that's one way that this is really useful, is that if you're looking for a keyword in the script or a certain section, you can do that. The other place that this is really useful is as I'm writing code, I may find that I had made a mistake. And so this is really helpful, especially when there's spelling mistakes. So let's just say, for example, in this file, there were two places that I had spelled the word student wrong and I had put an A instead of an E. One thing that's really nice is I can come up here, I can type in the incorrect spelling, and it will show it here. But notice there's this other spot right here that's called replace. And so I could put in the word student spelled correctly, and what R will do is it will go through and replace the student with student. And so I can do this on a one at a time basis. So for example, I can highlight the word student by clicking next, click replace, and that will become student. And then I could do that for the next one as well. And now notice it's saying there's no more places where it can find the word student because we fixed all of them. So I find this to be really useful. You do have to be careful because, obviously you want to make sure that you make a correct replacement. The other thing is, let's say you need to do a whole bunch of these and you're confident that everywhere you see a student, you want student, for example. You could also click on the word all and we'll do them at the same time. So just to illustrate that, let me put in 3 misspellings here, and then if I click the word all, it will tell me 3 of them were replaced, and notice these all become student. So this is something you do want to be careful to make sure you're making the replacements that you want, but I often find this to be really helpful. And then once you're done with this, you can always just click on the X and it will go away. The other thing that can be really helpful is you'll notice as I've been making comments in these scripts, I'll often use the pound or the hashtag sign here. And you'll notice anywhere that I have more than 2 of them, a little arrow appears over here. In RStudio, when you make comments with this symbol and you have more than 1 of them, what it does is it makes it collapsible until you hit the next section. I'm sorry, it's not more than 1, it's more than 2 of them. And so for example, if I wanted to collapse this header, I can click the arrow and it will collapse it, and then we can uncollapse it. And here's a much bigger section that's like that, and so you can collapse everything under facets. So this is one reason that making headers like this can be really useful, because what you can do is in your script, instead of having to keep on scrolling and scrolling and scrolling and looking for all the different sections, if you want to, what you can do is collapse all of the sections, and now it's really easy to scroll through. You can see the different sections, and let's say that you were really just interested in the histogram section, you can always expand that and have the piece that you want. And so that's just another way to organize code. By all means, you don't have to use this, But both this and that search functions are ways that make it easier to kind of organize and to look through the different scripts that you write. And so this is one reason, again, that using headers can be really useful, again, for organization purposes. All right, so I'm just going to go ahead and expand all these because we're going to use all of them in this video. And once I get that done, we'll go back up to the top and we'll look at all the different things that we can do with ggplot. All right, so again, we're going to continue looking at ggplot. The actual package in R is called ggplot2. It's one of the core members of what is known as the tidyverse. And all of the packages that are inside of tidyverse, they share this common philosophy of data and R programming, and they're designed to work together naturally. And so we're going to work with a lot of the packages that are inside of, or I should say functions that are inside of the tidyverse package itself. And you'll notice that the book that we're using for this course, it does the same. So the first thing I'm going to do is run library tidyverse. That is going to load the tidyverse so that I can use it. As a reminder, before we can ever load or use that library function, you do have to have that particular package installed. Now, in a previous step, we already installed the package. That's why I don't have to do it here. But if you are on a new computer or you do a new installation of R, you will have to do that install step first. And so just as a reminder, the easiest way to do the install step is to go up to Tools, Install Packages, and then look for the package that you want to install. All right, so the first thing we're going to look at are what are called facets. So previously we saw that a variable could be added to plot using the AES portion of the ggplot language. For categorical variables, we can also include what are called facets, and so we'll look at these. To illustrate this, we're going to use the orange data set. So the orange data set is a pre-built set in R, and when we have pre-built data sets in R, we've seen previously, for example, with the MT cars, we can read about that data set using a question mark. And so I'm going to skip this first line of code. I'm not going to run line 23 yet. I'm just going to run this piece. And notice here, if I do the question mark orange, I can read all about the data set here. This data set looks at the growth of orange trees. And so here there are three variables: tree, age, and circumference. So the tree is basically, it's an identity variable that tells us which tree we're looking at. Age is the age of the tree, and circumference is a numeric vector that tells us the circumference of a particular tree at that particular age. But notice that age was not, or the orange data set was not pulled into the environment. In order to do that with a pre-built data set, we can actually use the data function. Now notice I can use orange without doing this, but if I want it in the environment, one way that I can do is I can call data orange. And what you'll see here is now orange appears in the environment, and next to it, it has promise. And so next time we use the data orange set, it's going to pull it into the environment. So now if I run question mark orange, I can read about it. It's still not here in the global environment, but as soon as I run head orange and I pull down to the console those first 6 rows of the orange data set, notice it is now in my global environment. This is a step that it's often good to do, but you don't necessarily have to do. And so here, if we look at orange, we can see we have the tree, age, and the circumference variable. Now, one thing that you haven't seen before is maybe you have something in your environment up here and you would like to remove it. So notice if we right click on it, that doesn't really give us any options. And if we click here on the broom is going to delete everything. Now, of course, if we only have one thing in here, that would accomplish what we want. But another way that we can do this is with a line of code. And so the function that we want is detach. And so if I run detach orange, I believe it have to be in quotations. Well, there's always fun at coding here on the fly. So let's see what we need to do. So remember, if we ever try to use a function and we're not sure what's wrong, and this happens all the time, we can use the question mark. And so we're going to detach a database. All right, so it looks like we are supposed to give it the name. And often if you look down here at the bottom, let's look down here at maybe some options. So let's try detach name equal maybe. And it's still not happy with that. But then I remember that, wait a minute, we used detach before when we worked with that MATLAB function or package. So maybe since this is a pre-built data set, I don't want detach, I want something else. And it ends up that if you go and you do a Google search, you will find that detach isn't what we want. It's actually RM, which stands for remove. And so notice my environment is empty now. So I do this just to illustrate that when it comes to programming in R, you might have to try a couple different functions, do some searches. Often, when I code in R, I'll have to look up stuff. I'll have to maybe do some stuff that doesn't work and then do some stuff that does work. And so I don't want you as a learner to have this misconception that, if you're struggling or trying different things and they're not working and you're having to go back and forth, that's not a natural part of coding. It is. Even as someone that's programmed for a long time, I still have to go through and kind of talk through things and try different things. So just, doing that is a very natural part of coding, and I know when you first learn to code it can get really frustrating. And so again, I just show you this to illustrate that's normal. You're going to try things that don't work and then you're going to try different things. So anyway, so notice that the RM orange is now removed, my environment is empty. And so remember, the whole thing we were trying to do was to get orange to be in the environment so that we could actually look at it. And so one way I said we could do that is we could pull it forward with the data function. Now notice this time if I just run head orange by itself, head orange brings up those 6 rows here, but again, it doesn't appear in my global environment. So this is again one reason if we run the data first, then we do something with the data set, now it appears up here. And I'm going to remove that RM orange. Now, one other function that is useful is the ls function. And so if I call it with no arguments inside of it, it will tell me what objects are in my environment. And that RM function, instead of just giving it orange, if I leave it blank, it won't do anything here and orange still stays. All right. Let's actually go through and do some actual data visualization now. So again, we've got this orange data set. If I click on it, I can bring it up here. And notice what we've got here is we've got some different trees, 5 in total. Each of those trees is measured at a different age, and what is measured is the circumference of the tree. So let's first create a scatter plot with a separate plot for each tree. And so let's run this first bit of code to see what we have. And so notice here we've got a scatter plot of age on the x-axis and circumference on the y. So as we would imagine, we can see as the trees grow older, they have a larger circumference. But what's missing from this plot is that we really have 5 different trees, and so it's hard to separate which tree is which on this scatter plot. So one way that we could separate that is by using the facets. And so what a facet is going to do is it's going to help us create a scatter plot with a separate plot for each of the trees. So looking at this next piece of code, notice that the first two lines are exactly the same as what we just ran. The only difference is I put a plus sign here. And so remember, you can think of the way that we code in ggplot as containing different layers. So I'm going to add on an additional layer, which is called facet wrap. And notice I've got a tilde tree. And so what this is saying is that I want to do these facets by the variable tree. And remember, the variable tree here tells me which of those 5 trees I'm looking at, and I want to have n row equal to 1. So now if we run this, what we're going to get is a separate plot for each of the trees. And so this one is for tree 3, 1, 5, 2, and 4. And so remember, we can always make this bigger, stretch it however we need to, and now we have a separate image for each of those trees. Now, the next thing we could talk about is, what's the best way to visualize this? Is it to break it up into 5 different plots? Would it be to make each of the points for the trees a unique color? So maybe tree 3 is blue and tree 1 is red, and so on. And that's really going to depend on your individual data set and what specifically it is you're trying to visualize with that data set. If we're really trying to make a comparison of these 5 trees, it may be better just to have the single scatter plot with the different colors. And so one thing that I want to emphasize as we go through this video is I'm not necessarily advocating that the ways that I show you are the best ways for this particular data set, but really what I'm just trying to do is to illustrate all the different possibilities of things that you are able to do. And then when it comes to actually visualizing, a different data set, that will be a data visualization choice that you have to make, but you'll have a pretty big toolbox with different choices that you can make. All right, so another option that we might want to look into is, instead of separating this out and probably using the facets, another visual choice that we might want to make is, instead of points, maybe we want to have some smooth lines. So again, let's make a scatter plot. And so notice in this scatter plot, what we have is we've got a single scatter plot where we have a different color for each of the trees. So just as a reminder, again, ggplot is built by layers. So if we look at this code, notice the first layer, I just have ggplot and I've called the data set. The second layer is where I'm using that geom_point function and I'm defining the mapping, where on the x-axis I'm going to have age, the y-axis I'm going to have circumference, and then I want the color of the points to be based on trees. Now, instead of the points, like I said, we might want a smooth line. So the only difference I'm going to make in the next plot is, instead of using the geom_point function, we're going to use geom_smooth. And so here's what that geom_smooth looks like. Now, one thing that you'll notice is it does give in yellow here. It says they're using the method LOWS, and they've given a formula there. Now, the method they use is a little bit outside of the scope of this course that deals with basically the statistical background of how they're creating those smooth lines based on the points. By default, it's using LOWS here. LOWS is not always the best choice, and so you'll see in the homework for this week that goes along with this lecture, one of the things that I recommend is, for the data set that you work with, is to actually specify the method to use. And so for that data set, there's a method that's better. If you try to use the default LOWS, your plot's going to look, well, quite frankly, not good. And go ahead and try it with the default LOWS and you'll see what I mean. And so a different option is to use the LM method, and so that's incorporated there in the practice for this lecture. And then finally, we know that anytime we create a plot, we always want to have a good title and good X and Y axis labels. Now here, the x-axis is age and the y-axis is circumference, and those are good labels, but just to illustrate how we could change those, I've included 3 additional lines onto this plot. And so notice the first one is GG title, and we have circumference as a function of age. Now, this type of title is pretty common when you work with scatter plots, and what we've got here is it's really whatever variable is on the y-axis as a function of whatever variable is along the x-axis. And then XLab is how we can label the x-axis, and YLab is how we can label the y-axis. So if we run these, notice that we still have age and circumference, but they are now capitalized. We have a title here, which is circumference as a function of age. And then one other difference I made here just for illustration was in the plot before. Notice that we can click our buttons here to move back and forth. The plot before, we specified the lines using color. And in this one, we specified them using different line types, and so whether or not it's dashed or a solid line. And again, the choice that you make here is going to depend on your data set, and it's also going to depend on how you publish your plots. So you might think, having different colors looks great, and I would agree, especially if you're going to be publishing this plot somewhere that it is online or that it's always going to be printed in color. But if there's a possibility that wherever you're submitting this plot to is going to be printed in black and white, then having the different colors really isn't going to help you. And in a case like that, having different line types is probably going to be more beneficial. So again, in this video I'm showing you lots and lots of different options, but the option that you use will really depend on your data set and where you plan on publishing your different plots. All right, let's take a closer look at Geom Smooth. And so here are some different options that we could have. And so the first one is we could have a single line for all of the data. And so this is what that would look like with the Geom Smooth. And again, this isn't really helpful because we know that this data really represents 5 different trees, and so that doesn't do us any good. This is very similar to what we saw with the Geom Point, where again, we can't really distinguish which of the 5 trees we're looking at. But one thing to notice here is if we move between the Geom Point and the Geom Smooth, we can imagine if here is our scatter plot, if we were going to represent this with a line, the line would probably go pretty much through the middle of these points. And you can see that's pretty much how this looks like here. Now, again, we could have a different line for each of the trees. And this is what this would look like. So this is very similar to what we did up here with the Geom Smooth, but notice here we've said color equals tree, so we've specified how we would like that distinction, whether it be color or line type. Whereas here I've specified group equals tree. So with group equals tree, instead of having a different color or a different line type, it's really just changing the shading of the line for each of the trees. And again, if you're printing in black and white, this may or may not be a better option. And the more different categories you have, or in this case, the larger number of different trees that you have, of course, it's going to be harder and harder to distinguish between the different lines if we're just looking at a shading gradient like we are here. And then let's look at one more here. Here we've specified the color. And so notice when we use the color equals tree, we get an automatic legend, whereas when we use the group equal tree, we were not provided a legend. So that's another benefit to using either the color or the line type option, because with both of those, ggplot does automatically generate that legend, whereas if we set the group equal to tree, it did not automatically generate that legend. And so if we go back, here's the one where we had the different line types. See, we do get that legend. And so again, this goes back to that idea as if we're creating different plots, we're probably going to want to try to play around with those plots, see what looks better. So this is really one benefit to first creating a script before you would ever create a notebook or some kind of report that you would send someone. If you work in a script environment first, it's really easy to just go ahead and create different types of plots to kind of play around. Do you want different line types? Do you want different colors? How do you want your axes to look? You can include all of this in a script very quickly. And you can think of this as kind of the background information or the exploratory information for you as the person that's summarizing or analyzing the data. Now, of course, if I were going to generate a report to send someone else, and let's say I might do that in a notebook, which is a really good way to do that, I don't want to include this same plot of age versus circumference over and over again for that person that I'm sharing with. Really what I want to do is, based off of all these ones that I've made in my script, I've looked at all these different ones, I've explored all of these. I mainly picked one of them that actually go in my report that I send off to someone else. And so I think that's a really important thing to note, is that as the person analyzing the data, you're going to make lots and lots of plots, lots of comparisons, lots of descriptive statistics. We do a lot of exploratory stuff, but that doesn't mean that all of that makes it into the report that we send later on. So just because you made something doesn't necessarily mean that you report on it, because again, you might be comparing the same variables and just, really what you're looking at is different ways to visualize that data. All right, the next one we're going to look at is called display multiple genomes. And so again, let's start with an example here. So here we have combined both the point and the smoothing. And so this is an even better way than what we saw it before when we were making the choice between the lines and the points. Now we have them all together. And so in this example, again, we're ignoring the fact there are different trees, which isn't the best, but now we've got both that line and the points, and we can see that overlap. Now, one thing to notice is in the first one, I created the points and then added on the smoothing. This time I'm going to do the smoothing and then add on the points. And so in either case, this looks fine. And again, remember, you're getting this warning down here. It's not even really a warning. That yellow is just telling you the smoothing method that was used was low S. Now instead, maybe we want to have all of the points or the color based on tree, which we know really is better. So here again, the first thing I'm going to do is draw those points. But notice this time, since I've got that different color for tree, I've left geom smooth with an empty argument. So why did I do that? What is the difference? So if we compare to what we did before, up to this point, we've used ggplot data equals orange, and then the mapping we've put in both geom smooth and geom point. But notice for both of these, the mapping argument is actually the same for both geom smooth, and the mapping argument is the same for geom point. When you repeat the mapping argument for your different geom functions, what you can do is actually include that mapping argument in the ggplot call. So notice down here, I've got that the mapping equals AES, x equals age, y equals circumference. I need that for both the geom point and the geom smooth, so I can just put it up here for the geom plot. And so that's why the geom smooth is just left open. Now, one thing that I do want to do is I do want to base color for the points based off of what tree I'm looking at. So I add in this additional mapping argument for color into the geom point. Now if I wanted to do this for both the smoothing lines and the points, so now instead of having the single line, I want to have a line for each of them. Notice that I can add the color equals tree into the geom plot call because I'm going to feed that into both of these. And here's what that looks like. So notice now I've got a line for each of the trees, and really I've got a point for each of the trees, but what happened is if we drew these lines over top, the points kind of got pushed into the background, because remember these are done in layers. So in other words, I did the point layer, then the smooth layer, and so the points kind of get hidden in the background. Well, we could always reverse those and do smooth and then point, and we get a much better looking plot. So again, that goes back to this idea of when we're working in scripts, there is going to be some trial and error as to what's going to make the best looking plot. And then of course, when I write a report, I don't want to include all these other things that I played with or I created. Really, it's this last one that looks the best so far, and that would be what I would want to include. And to be even better, I probably want to, put a title on this. I might want to change the capitalization on my axes. There's always things that we can do to make these plots look better. All right, so next we're going to look at bar plots and histograms. So for this one, you're going to want to call in that student data set that you got off of Canvas. So remember, whenever we're reading in a data set, the very first thing that we want to do is we want to set our working directory. A couple different ways we can do that. We could Over here, go to Files, click on these three horizontal dots, navigate to the folder to where the dataset is located. I've already got that folder here, and then I can click on More, Set as Working Directory. That will auto-generate the code down below rather. Remember, it's always a good idea to copy this and go ahead and paste it into your script. I'm going to use the read.csv to read in this data set. This data set does have headers, so I have header equal true. Okay, now that that's read in, I can see it up here. Always a good idea to check the structure. So I can go through here for each of the variables. I can see if they're read in as a character or if they're read in as an integer. Want to make sure that anything that's numeric did get read in as an integer, and it looks like everything looks good. I can look at the first six rows of the data set down below. Again, just to kind of check things. And then I can view the data set using the view function. And that's going to pull that into a separate window. Now this is a pretty good sized data set. It does have 395 rows of 35 variables, but it's not so big that R can't handle it in the viewer. It'll just run a little slow. Alright, so let's see some ways that we can view this data set. So the first thing we could do is create a histogram of age of the students. Now, as a reminder, histograms are appropriate for quantitative data. Bar plots are appropriate for categorical data. They both look very similar. The primary visual difference is that in histograms the bars touch, and bar plots the bars do not touch. So let's make a histogram of the age variable. So notice here in my first line in ggplot, I'm going to call the data set, and then I'm going to add on the geom histogram, where for mapping, notice I have x equals age. There's no y for the histogram, and that's because a histogram is used to visualize just a single variable, whereas before we were looking at scatter plots, which can be used to view two variables. So running this. Here is my histogram. Now you might say, but you said that in a histogram the bars touch. Well, the problem here with this particular histogram is that the way that it's reading in the bars, where age is represented by a whole number, it's causing this to look funny. So let's make this look better. So to do this, I'm going to call in ggplot. I'm still going to call in the student data. And notice here's another example where I can move that mapping into the ggplot call. It also works just as well if I move it into the geom histogram. Now what I'm going to do is I'm going to change my bin width, and that's going to help quite a bit with this odd looking spacing with this histogram. I'm going to set color equal to blue and fill equal to red, so we'll see what these do in just a moment. I'm going to give it a title and label my x-axis. So notice now by changing my bin width to something that's more appropriate for this particular data set, see that those do touch now, so this looks like a histogram should. Fill equals red, that fills in the colors of the bar, and color equals blue gives a blue outline. So that's not quite intuitive. So of course I wouldn't recommend actually coloring your histogram like this. I did this just for illustration. I would probably really do fill is equal to blue, and that looks much nicer. And for color I might do black, just so that has a nice sharp outline to it, and that looks much nicer now. And then we could always look at a summary of that age, and we can see that it has a minimum of 15 and a maximum of 22. And so again, this looks much, much nicer. All right, so next we'll look at bar plots. Bar plots are very similar to histograms. Again, the big difference is that bar plots are appropriate for categorical variables. Histograms are appropriate for quantitative variables. So here we're going to make a bar plot of father's job. And so here we have spaces between the bars, which is exactly what we want to have. And so based on father's job, we can see there are 5 different possible categories that they could have responded. Now, one thing with bar plots that's often useful is instead of count or frequency, we often want relative frequency or percentage. Whenever you're making a bar plot, if you're working with sample data, that is almost always going to be true that you really want proportions on the y-axis and not counts on the y-axis. The reason for that is for example, if you have 10 people in your sample that fall into a certain category, that's really not helpful in itself unless it's in terms of the total number of people in your sample. So if in total, you surveyed 1,000,000 people and only 10 of them do something, versus if you only surveyed 20 people and 10 of them do something, that's a very different picture between those two. And so having relative frequency or having percentages on your y-axis is more informative for that reason. So in a bar plot, in order to put those proportions, relative frequency, percentage, whatever you want to call it, on the y-axis, what you can do is you can use this group equals 1 trick. And what it does is it keeps it from grouping by job. And so what that looks like is in the geom_bar call, you're still going to have the x equals f job is the father's job variable for this data set, but you're just going to add in these two additional arguments, and you won't change these for different variables. These two are pretty much always going to stay the same. That's what these two arguments look like. So even if you were looking at a different categorical variable, you wouldn't change any of this syntax. And notice if we run this, we now get proportion here. And we can now move across here to see, a little under 50% responded other. We had a little above 5% reply at home or health, and that's probably about 8% said teacher. All right, so one of the next things we're going to look at is what is called stat function. So again, let's create a bar plot of father's job, and here I want the counts. And the reason for that is I want to use this to help illustrate other stat functions. And so notice here I used stat count instead of geom_bar to make that bar plot. And so we're using, instead of the geom function, we're using a stat function. And there's lots of other ones that are available. So let's run this piece of code and look at it. And so in this example, what we're doing is we're still using the data set, but instead of stat count, we're using stat summary. So in stat summary, what we can look at in the mapping is we can compare father's jobs to number of absences that the students have. And then what we can define here are the min, max, and the median. So this is just another way to visualize this data. So for each of these different types of father's jobs, what we have is the minimum number of absences, and it looks like for all of these groups the minimum number is 0. We get the median for each of these, and notice the median for each of these types of father's jobs is pretty much the same compared to the maximum. And notice for those in the services, the maximum number of absences is much higher compared to those at home or health. Now we probably need to dig into this a little bit deeper, because we don't know, is it just a single student had this many absences, and then really we don't have many data points until we get back down into the lower part of the range, that we see here and here. So there's always these questions that we can ask, but again, just another way that we can visualize that data. Just like with all the different plots that we've seen, there are lots of different bar plot options. So again, using that stat count to create the bar plot, we could also just as easily use that geom_bar. We see that color changes the outline of the bars. Fill is going to change the fill color for the bars. We could also bring in another variable. So here we could create a bar plot of father's job with colors corresponding to failures. And so failure is numeric. It stands for, if it's 0 to 3, you'll have that many fails. Otherwise, it's 4. And so here what I'm doing is I'm first going to take the failures from the data set and convert it into a new variable called failures.factor. So how I do this is I call failures from the data set, I'm going to convert it as to a factor. And originally in the student's data set, I've already ran that code so you won't see it, but originally this failures.factor didn't exist. So I use the $sign to add it in. So the $sign can be used to call variables from a data set. It can also be used to add new variables to a data set. So now using that new variable we just created, here's what this looks like. And so notice here we're really comparing two different categorical variables, father's job to this failures.factor. All right. Now here, the way that this is done is we have those failures stacked on top of each other. There are lots of different positions that we could have, and so I'm going to show you some of those different positions here. Which one you use will really be dependent on how you're trying to visualize your data. Right. So again, same plot, but I'm going to change the position to be identity. And so this is going to place each object exactly where it falls in context of the graph. And it's not very useful for bars because it's going to overlap them. So here's what that looks like. So really these bars are overlapped on top of each other. I don't recommend position identity when you're working with bar plots, but there are other times that position identity can be useful. Position equals full. It works like stacking, but it makes everything the same height. This is a great way to compare proportions across groups. And so, for example, we see for those that are teachers, there's a much higher percentage in the 0 category compared to those that were at home in the 0 factor category. For the at home, other, and services, the 3 appears, but it doesn't appear for health and teacher. If I'm comparing two categorical variables, this is one of my favorite ways to make that comparison. There's also position equals dodge, which places overlapping objects directly beside each other. So this is a side-by-side bar plot that you're also probably pretty familiar with. I like this one as well. When one of my categories has a bunch of categories, so here father's job has 5, failures factor does 4. I think this is kind of pushing it for the side-by-side bar plot to be useful. If we had fewer categories, I like these more, but especially if you get into where you've got 10 categories for one of your categorical variables, I don't find this type of plot particularly useful. Now, the last one we're going to look at is jitter. Jitter is not used with bar plots, but it can be really useful for scatter plots. And so what it does is it adds a small amount of random noise to each point. Now, of course, if you're using this, you would want to say that, this was how the data was visualized. But just to give an idea here, two of the variables in the data set are G1 and G3, which are different grades. So if I make this plot, notice because grades are recorded as whole numbers here, what happens is you get a lot of overlap in the points. So this particular data set, if we go back up, has 395 observations, but there's not 395 points here. What's happening is some of those points fall on top of each other, and so we can't really see how many they are. Jitter, what it does is it adds in just a little bit of random noise, so the points move slightly. And we still get the same overall pattern for the data, but since each of the points have been shifted just a little random amount, we actually now get 395 on the scatter plot, and we can get a better feel for where the clustering of the data is. But again, if I'm going to make this type of plot, I'm going to make sure I denote that a little bit of random noise was added to each of the points for visual purposes. All right, so that concludes our different pieces about ggplot. Again, the structure of ggplot isn't necessarily intuitive. So the important part is to really get in there and kind of play with it, rerun the code that I have here, go through and make sure you know what each of the pieces are doing. And so for each of these, I kind of went through some of them pretty quickly because I want you to go in and rerun them and to think about, okay, well, what happens if I change this piece? Why is this piece here? Why is it the same if I do this one or this one? And if you kind of take that deep dive with what we're doing, here in this video, as well as with the lecture practice, that structure is going to, start to make more sense. it's not very intuitive the first time you see it. You really do have to work with it and try different things. And again, just keep in mind, you can't break anything. You know, try different stuff. You're not going to hurt anything, and that really is the best way to learn when learning to code R. As always, I'm more than happy to answer any questions that you have. You all have been asking great questions so far this semester, so please keep that up. And then the very last thing I've got here is just a reminder that don't forget about those cheat sheets. They can be really useful. Previously, we saw the cheat sheet for creating our notebooks, but there's also cheat sheets for other things, including ggplot. So here, if we go and we click here, notice there's one that's called Data Visualization with ggplot2. I'm going to download that and bring that up. So here is another useful cheat sheet. And so you'll notice here they talk about a lot of the different geomes, line segments, all different kinds of stuffs here. Here's those different stat functions that we talked about. Now at first, if you were just to dive in and start using one of these cheat sheets, I think they can be kind of confusing because it's a lot of information crammed into a small area. But if you first, play with the code, get used to the structure, and then come to the cheat sheet, I think you'll be able to see how these different pieces fit in and how you can, use some of these different things in your own plots. So again, as always, if you have any questions, please let me know. Keep up the great work, and I'm always happy to help in any way that I can.